observed inside crystals of beryl, a type of emerald, caused by bizarre quantum mechanical effects that let the water molecules face 6 different directions at the same time. Under normal conditions, the 2 hydrogen atoms in each water molecule are arranged around the oxygen atom in an open V shape, sometimes compared to a boomerang or Mickey Mouse ears. But in a new experiment, scientists have found that hydrogen atoms of some water molecules trapped in the crystal structure of the mineral beryl become smeared out into a 6-sided ring. The surprisingly strange physics of water. We already know from lots of other studies that as you put water in smaller and smaller pores, it starts to affect the properties of the water. The freezing point drops, the density changes, all sorts of things. So, we wanted to know, if you made that pore so small that you only can get a single molecule of water into it, what would that do to the properties of water? What happened next was unexpected. Anovitz told Live Science, "We knew that natural beryl would have water in these channels in the structure, so we could go and look at that and see what the properties were," he said. "But we didn't know that the properties would turn out to be so strange when we looked." Sinister Sparkle Gallery, 13 Mysterious and Cursed Gemstones, seeing a new state at ORNL's Spallation Neutron Source Facility. The new experiments reveal that the molecules were forming a double top shape, with the proton nucleus of each hydrogen atom delocalizing into a 6-sided ring around the central oxygen atom, the researchers said. Measuring the molecules, Alexander Kolesnikov, a physicist at ORNL and the lead author of the new paper, said additional studies at the Rutherford Appleton Laboratory had determined that the kinetic energy of the hydrogen protons in the 6-sided water molecules was about 30% lower than in molecules of water in its normal state, or bulk water. That is a direct indication that this is a quantum property due to the tunneling of water in this beryl channel, Kolesnikov told Live Science. In classical terms, the kinetic energy would be expected to be something comparable to all other bulk water. This is not a new phase of water, like ice or steam. It's not completely in the gas phase, but it's close to a gas phase, he added. But at low temperatures, due to quantum delocalization, the kinetic energy of the protons significantly decreases, and they propagate under this energy barrier. So, I would say this is kind of a new state of the water molecule. Anovitz said that quantum tunneling was known to occur in other substances, but that the effect was usually limited to subatomic particles rather than larger particles like water molecules. Quantum tunneling was also known to take place among hydrogen atoms in methyl group molecules, which are arranged in a triangular pyramid shape around a carbon atom. But the molecules look the same shape after the tunneling transition, he said. With water, when it's moving around the 6-fold axis in the beryl channel, it doesn't look the same anymore, and it's something that's never been seen before, Anovitz said. The findings were published April 22 in the Journal of Physical Review Letters.